Okay, today we're going to take a look at the inner planets. With the inner planets, they all have rocky crusts, dense mantle layers, and very dense cores. So that's going to be the main determining factor for our inner planets. And the first of these inner planets that we're going to look at is Mercury. And Mercury is the closest planet to the Sun. And it is also the smallest planet in our solar system. Mercury is going to turn on its axis once every 59 days. So one day on Mercury is like 59 Earth days. So it rotates on its axis very, very slow. But its revolution around the Sun is very, very quick. Because it is the closest planet to the Sun, it has a very, very small path, or a short path, around the Sun, and it only takes it 88 days to make a complete trip around the Sun. So it does make a lot of revolutions around the Sun in comparison to the Earth. When we look at a picture here of Mercury, it does look very much similar to Earth's moon. It's only slightly larger than Earth's moon. It does not have an atmosphere. It's very, very similar to the moon, and that also has a lot to do with its look. So with no atmosphere, it does not have any weathering and erosion that's going to take place. Some of the other important things to notice about the moon: on the side facing the Sun, it is going to get very, very hot because it is close to the Sun, and the solar rays are going to be very, very hot. However, on the nighttime side, it is going to be very, very cold. So it is very hot daytime side and a very cold nighttime side. Again, it doesn't have an atmosphere, and it is the closest planet and smallest planet. Moving on from there, we have Venus. We like to refer to Venus as Earth's sister planet because it is very, very similar to Earth in terms of its size and gravity. Only slightly smaller than the Earth. Somewhere in the 90% of the Earth's size. So, you know, if you weighed 100 pounds on Earth, you would weigh relatively the same thing on Venus, just a couple pounds less. Not like some of the other planets where you would weigh a noticeably different amount, or gravity would push down on you at a noticeably different amount. Venus rotates from east to west, opposite of that of the Earth's. So on Venus, instead of having the Sun rise in the east and set in the west like it does on Earth, the Sun would rise in the west on Venus and set in the east. It's one of the few planets that actually does rotate on its axis in the opposite direction that it revolves. So it revolves around the Sun in the same direction as the other planets. Almost like if you're looking down on the solar system, it would be in a counterclockwise direction. But instead of rotating west to east like the other planets do, or most of the other planets do at least, it rotates east to west. So that's very, very odd. Some different thoughts on that are like meteoroid impacts that would have gotten the planet spinning in that opposite direction. Its surface is covered in active volcanoes. It's the most volcanically active planet in our solar system. It's not the most volcanically active place in our solar system. And when we get out to the moons of Jupiter, we'll talk about the most volcanically active place in our solar system. But it is very, very volcanically active, and lava flows are a big part of the surface of Venus. Venus's atmosphere is mostly carbon dioxide, and its yellow clouds are made from sulfuric acid. So a lot of sulfur coming out of that very, very active volcanic areas where it has these gases kind of seeping out through the surface and into its atmosphere. Here is our picture of Venus, and just as a quick recap, the four main things that we'd want to know about Venus is that it has a very, very thick atmosphere. It's like an extreme greenhouse effect. It's very, very close to the same size as the Earth in terms of its mass and gravity. Venus is the hottest planet in our solar system. Even though it's the second planet from the Sun, it is the hottest planet, and a lot of that has to do with that very, very thick atmosphere and that extreme greenhouse effect. But Venus's temperature on average is over 400 degrees Celsius. and that's daytime and nighttime. Because of those very, very thick atmospheric clouds, it's like adding lots and lots of blankets to the planet, and a lot of that internal heat from the planet doesn't escape. It doesn't give off heat. Where on Earth we have an atmosphere that lets some heat in and does let some heat back out to space so the planet doesn't get too hot. On Venus, it traps and bottles up a lot of that heat and doesn't let the planet really cool off with that thick atmosphere. And the fourth thing is very volcanically active. Next we have the Earth. We spent quite a bit of time this year talking about the Earth, so I'm not going to slow down here too much, but it has a strong magnetic field that protects us from the solar wind, and that's what produces auroras on the planet. Because we have a larger core, we're able to have a stronger magnetic field. Earth is one of the few planets that has liquid water on its surface, so that is extremely unique, and we feel one of the main reasons why we're able to have life on the planet. Because we were able to have liquid water, and we feel that that's a necessity for having life anywhere in the universe, is that liquid water needs to be on the surface. And here we have about Earth's atmosphere being very thick, and it holds in just enough heat to keep the planet warm so we can have liquid water, and lets out enough heat so as not to cook the planet where the gases would be a vapor or burned off of the surface. And the last thing down there is our atmosphere has very little carbon dioxide, mostly oxygen and nitrogen, but very little carbon dioxide, which is also very unique in comparison to a lot of the other planets. So as a review for Earth, liquid water on the surface, strong magnetic field, protects us from that solar wind, an atmosphere with little carbon dioxide that's made up of mostly nitrogen and oxygen, and we're the only planet that we know of that has advanced life, or at least the only planet that we've come across with advanced life. And next, or last of the inner planets, is Mars. Mars, being the last of the inner planets, has an orbit almost twice that of Earth's, going around the Sun at about 687 days. Mars is roughly half the size that of Earth. I believe its gravity is 60% of that of Earth. So if you weighed 100 pounds on Earth, you'd weigh about 60 pounds or so on Mars. On a summer day, temperatures can reach up to 27 degrees Celsius, or about 80 degrees Fahrenheit. But on a cold winter night, temperatures can get down to and that's negative 125 degrees Celsius, or minus 193 degrees Fahrenheit. So while Mars, at least in the summertime, or in its summer when it's very warm, it does seem like it would be possibly livable, or a candidate to possibly be able to get life on there. Its winters are very cold, and a lot of that has to do to its thin atmosphere. There's a lot of evidence that water was on the surface of Mars. We find riverbeds, canyons, 5 times larger than our own Grand Canyon. Mars has ice caps that would grow in the winter and shrink in the summer, but we think that a lot of its water is maybe underground, but it is no longer on the surface. So Mars is a very interesting planet in terms of how the potential for life, or for trying to go there to study the planet. We have rovers on the surface, and we can take a look at the planet. Google Earth does a very good job of giving you like a virtual tour. We look at it in class. I don't put it on the videos because it takes a lot of time to kind of load and go between different locations, but it is very interesting to take a virtual trip to places like Mars or the Moon, or get a look at some of the different celestial bodies with Google Sky. I mentioned there that it has its ice caps that grow in the winter and shrink in the summer. Its atmosphere, while it is very thin, it's about 95% carbon dioxide. A big reason for its thin atmosphere is because it has a very weak core with a very weak magnetic field. So those solar winds that come out of the sun kind of ripped apart the atmosphere of Mars. At one time in its history, within the last couple billion years, Mars was probably much more Earth-like with liquid water on the surface, but after its atmosphere has been stripped away as bad as it has, that's no longer really a possibility. We have here our picture of Mars. And a couple things that I want to point out, the four main things here for Mars. Has frozen water, a thin atmosphere, its gravity is 60% that of Earth's, and it is the last of the inner planets. So I'm going to stop this video on the inner planets now. If you have any questions, you can stop by in class and ask.